Hello grade 9 students, welcome to another virtual class. I am Miss Madhu Vadke. Currently we are studying quadrilateral chapter, and in the last video class we have learned about a new theorem called midpoint theorem. I hope everyone has gone through the proof explained in the lesson. In today's video lesson we will extend our understanding about this theorem by performing hands-on activity. The aim of this activity is to verify the midpoint theorem of a triangle by paper cutting and pasting method. To do this activity, you must have some previous knowledge. Number 1, you must know the statement of midpoint theorem. So let's recall. In a triangle, if we join the midpoints of two sides, then the line obtained will be parallel to the third side. So if D and E are the midpoints of AB and AC, then this line DE will be parallel to the third side and half of it. We are also going to use the concept of parallel lines and transversals. So if we have two parallel lines which are cut by a transversal, then the corresponding angles so formed are equal. Following material will be required to do this activity: marble paper, a pair of scissors, glue and geometry box. Let's go through the procedure step by step. The first step is to cut triangle ABC from a marble paper. The measurements of triangle are not given here, so you are free to choose any measurements to construct your triangle on the marble paper. So choose a proper size such that it is neither too big nor too small. The second step is to obtain midpoints P, Q and R of sides AB, AC and BC respectively by pinch folding. For example, to obtain the midpoint of BC, you have to coincide these two vertices B and C, and then slightly pinch on the fold that you obtain. That will be the midpoint R. And if you don't understand how to obtain the midpoints by folding, then you can simply use your ruler to mark the midpoints, but make sure that they are accurate, because if done incorrectly, then the figures obtained during conduct will not align. Third step is to join points P and Q by making a sharp fold. Then obtain a replica of this triangle ABC and repeat steps 1 to 3 on the replica. Now we have two triangles. One triangle is to be pasted as design, and using the other triangle, that is the replica of triangle ABC, cut triangle APQ and align it such that AQ coincides with QC in the interior of the triangle. Now let's perform this activity by following these steps. The first step is to obtain a triangle ABC using a colored marble paper. Now obtain the midpoints of side AB, BC and CA by pinch folding. That means fold along AB such that vertex A coincides with B. Now pinch on the fold obtained on side AB to create a very small crease. Using this crease, mark the midpoint of AB. To get the midpoint of BC, coincide vertex C with B and pinch on the fold on side BC to create a very small crease. Using this crease, mark the midpoint of BC. Same way you have to obtain midpoint of AC. Now if you are not able to get the midpoints in this manner, then you can use your ruler, measure the sides and then find the midpoints. Label these midpoints as P, Q and R. Now keeping the ruler aligned with points P and Q, you can make a sharp fold. So this fold is line PQ. Again, if you don't understand the method of folding, just use your ruler and join PQ. So we have AB equal to BP in this triangle and AQ equal to QC. And BR equal to RC. Now cut a replica of this triangle. Now cut a replica of this triangle and repeat all these steps on this triangle. We will use this replica for conduct. Paste one of the triangles as design. So your design should look like this, with one triangle completely labeled, showing the equal segments AP equal to PB, AQ equal to QC and showing line PQ. Also you have to show point R, which is the midpoint of BC. So this completes your design. Let's move on to conduct. The replica that we are using for conduct also needs to be labeled exactly in the same manner that we have done in design. To perform the conduct, we will cut this triangle along the line segment PQ. On cutting along PQ, we will have two cutouts of this triangle, triangle APQ and quadrilateral PBCQ. Now paste this quadrilateral BCQP on plain side of the journal and give the heading as conduct. Using your ruler, extend BP and QC to meet BP at point A. So these lines PA and QA are to be drawn with pencil so as to complete this triangle ABC. Mark the segments that are equal. So this cutout of the triangle, which is triangle APQ, is to be labeled as shown over here. And then this triangle APQ is to be aligned such that AQ coincides with QC. If I align this red triangle APQ on the red quadrilateral, it will be difficult to see whether they both are aligned along QC. So only for the purpose of this video lesson, I will take a yellow cutout of the same triangle. So these two triangles are identical. I have chosen yellow color so that it is easier to see whether the sides QC and AQ are aligned. However, in your journal you can stick to just one color. Now place triangle APQ in the interior such of triangle that AQ ABC and QC coincides. Now apply glue only at the corner of this triangle, that is at the vertex Q, only at this part, to show that angle AQP coincides with angle QCB. So these two angles are equal, but these two angles are made by lines PQ and BC cut by transversal AC. That means these two angles are forming corresponding angles. And therefore we can say PQ is parallel to BC. That is the first part of this theorem. Also, point P coincides with R. This means that PQ is equal to RC. But we know that R is the midpoint of BC. So we can say that RC is half of BC. So this implies PQ is half of BC. So that proves the second part of this theorem. So we have shown that PQ is parallel to BC and half of it. Now all these observations that we made from the conduct are to be written point-wise. Number 1, angle AQP exactly covers QCB. Angle AQP exactly covers angle QCB. This implies that they are corresponding angles made by PQ and BC with transversal AC. And therefore we can say that PQ is parallel to BC. Also P coincides with midpoint R of BC. And therefore PQ is equal to RC equal to half BC. These are the same points that I have written over here. Hence, we have verified midpoint theorem, which states that line joining the midpoints of two sides of a triangle is parallel to the third side and half of it. With this, we come to the end of this video lesson. Your assignment for today is to complete this activity in your journal neatly. See you in the next class. Until then, goodbye.